Okay, so remember this is a problem that we were just working on in part 1. And now let's continue on looking at some points about this. It's asking whether or not it has a minimum or a maximum value. All right, well, the graph that looks like this would have a minimum value right here. And a graph that looks like that would have a maximum point right up there. And we could easily see from the equation if this one has a minimum or a maximum based off of the x squared, the coefficient of x squared. If it is positive, it's going to look like this. If it is negative, it's going to look like this. So since this one is negative, it is going to have a maximum value. Okay, so now it's the same equation. It says state the minimum or maximum value. Well, we know that it is going to be part of the vertex. So we have to find the vertex by doing the axis of symmetry. So that would be negative 2 over 2 times negative 1. So negative 2 over negative 2, or just 1. That is the x-coordinate, but that's not how high it goes. We would figure out how high it goes by substituting 1 into the equation. So we need to go ahead and calculate that. And we can get 4 as our answer. So we know that that graph goes up to a height of 4. So the maximum height is 4. All right, so consider the domain and the range. So we don't have a complete graph of this. We could do a little bit more and figure it out. But we actually don't need to do much more because we know that it is going to be a graph that goes up to a height of 4. Oh, that scale's not very correct, but so perhaps it looks like that. Perhaps it looks like that. We're not exactly sure what this looks like, but all we know is that it goes up to a height of 4 and that it has a maximum value. So now we need to figure out what the domain and the range is. So remember, domain is like we drag this line across the x-axis, and when will it intersect the graph? Okay, even out here, if our graph looks like the red one, it will intersect eventually because the parabola continues to get wider and wider and wider and wider. And since it goes on for an infinite amount of time, eventually they'll intersect. So the domain is all real numbers. And for all quadratics, the domain will be all real numbers. Now the range is when we look at it the other direction. When will this intersect the graph? Well, it doesn't matter how wide of a graph it is or where the vertex is shifted. It will always be touching as long as it's 4 or below. It will not be intersecting up here. Oops. So we would say that the range is when y is less than or equal to 4. All right, this concludes the second part of the video, so we have one more section to watch.